Hello everyone. Today's going to be a video which is mainly microscope and like screen capture work because we're going to be talking about small stuff. As you can see under the microscope, I have three like complete balances in the tray, and that's what we're going to be talking about because I need to address something that somebody commented about a while ago. We'll put the comment on screen, and they said that the balance itself, like the balance wheel itself, didn't have those screws like the modern ones do. It was on the video that about the cylinder escapement, and I told them, well, that wasn't always the case, because indeed there was a time period where the screws were very prominent. However, most modern watches will not have the screws anymore, and I'm going to talk about why that is. Well, why do we need the screws in the first place? Why don't we use the screws anymore? And then we'll show you a few balances. So, why are there screws on these balances in the first place? Like, why was the need for screws there? The need for screws was there because within a watch, within the balance, we want the center point of gravity to be in the middle. So right where the axle is. That's where we want the center point of gravity to lay. If it isn't there, then we introduce a fault, a timing fault, which is something I'm going to address later on. But for now, just important that we want it to be in the middle. So, how do we get it in the middle? Well, if you have the screws, you can use little weights. So you would get the screw out, and then you would put a little weight on there, and that solves it. So you would measure it. Either on a special tool, which you would basically put it on. It's like two little like ruby whales. You put a balance on there, and you let it roll over it, and of course the point that is the heaviest will always point downwards. So that's how you know. But that's a very coarse way of measuring it. So that's good to get like the first faults out. And then you go over to your time grapher, and there you see, there you can measure the real difference, like the real fault, to a few seconds a day, basically. But that's something I'm going to explain later on. But yeah, so that's how you could do it. So you could add weights. But not all of them have them, so how do they do this? Well, I'm going to show you one of a pocket watch, which shows you really clearly. So you can see, I assume this balance wheel was cast at one point, because you can see it's not like a really defined shape. However, here you can see that purposely they drilled a hole in there. Instead of adding material, you can just remove material to get the same thing, to get the center point of gravity also in the middle. Works just as well. So we've seen this one. This is a really old pocket watch. Then we had a point where these were very common, the screws. And now, this is a modern watch. This is the balance wheel for a modern watch. As you can see, no screws. So how do they do it? Well, can't really. Well, maybe you see it a little bit, but here you can see those two dots. However, if I tilt it a bit, you might be able to see. Yeah, there you can see there's a slit built into there, like right here, a little slit. So that's the modern way of doing it. So what they basically have is they have a machine now in the companies who produce those, and they have a machine. It will determine where it needs to mill out the slit, and it will do it. There's also another interesting thing about this. The more you need to take away, the lighter your balance will get. But you need to pair it with a hairspring, and the hairspring also, like the hairspring is calculated for a certain amount of weight. So what I will do is, those hairsprings have tolerances, so they will bend them, and then the more, like, they will make pairs in the factory. Like, the more weight they take off, you get a lighter balance wheel, so they will pair a lighter one with also a less stronger hairspring. That's why it's really hard on a watch to replace either of those. So if you have like a balance wheel that has a dent in it, you can't really just pick a hairspring and hope it will work. It will kind of work, but you will never get accurate timing. Same goes the other way. Or let's say you might have messed up the hairspring. Well, you can't just take a hairspring from another watch and put it on there, because like I said, they are basically regulated in the factory, and they will pair them. And you can get lucky, but yeah, it's not supposed to. So keep them as a pair. Like one of my old teachers would say, like the balance wheel and the hairspring, it's a marriage. You don't touch the married couple, or you get in trouble. So yeah, let's hop on over to screen capture now, so I can explain why we want to have the center point of gravity in the middle of the balance wheel, and how we can measure it too on a time grapher. So, see you there. So, here we are. I screen capped, I basically just took a screenshot of Clockwatch, Swiss lever escapement, so I can draw on this and explain you. But before I go out with explanation, center point of gravity not being in the middle only affects the watch its timekeeping performance in vertical position, not in horizontal. And I will show you right away why that is. So let's say your balance has a heavy spot about here, right? So because your balance is going back and forth, when it's here, when it's going down, it will accelerate your balance, because, well, gravity is going to pull on it. If it's going up, it will delay it a bit, however, not in the same way, and that's why it only cancels out each other if you have an amplitude of 180 degrees. That's why we're never going to try to find a fault like this on 180 degrees. And it's basically, the effects of this are negligible in between 180 and 220 degrees of amplitude. That's why, for example, Rolex aims for 220. You're probably wondering why don't they aim for 180, because there it truly cancels each other out. Well, 180 you still have it's basically too slow. You have a lot of influences from the outside, so that's why you avoid that. But it can also be differently. For example, if it's right here, well, it will be like working against each other. Like if you're going up right here, then yeah, it's going to slow it down. So that's basically the way we find it. If we're looking for center point of gravity being off, we will look, for example, if it's here. Here's your heavy spot. When the heavy spot is down, when the watch is physically pointing down, that's where you heavy spot. You will have the fastest speed on your time grapher. So that's how you know where the weight is, the heavy spot is, because it will go faster because gravity pulls on it. And yeah, that's how you know. And what you will do here in this case, if the heavy spot is here, you will either have a tiny weight here to compensate for it, or what you could do if you have a balance wheel without the screws, you will just remove weight here. You will have like a tiny burr cutter. Usually watchmakers make them themselves. I made mine while I was at school to just ever so slightly take a bit of material off. So that's how like you get your center point of gravity in order. However, there are a few watch manufacturers that also do the complete regulation. They completely regulate their watch, timekeeping wise, weights. For example, Rolex does that, and Jaeger-LeCoultre does that as well. And that opens up a whole different kind of way of regulating it, because you can, I talked about like the weight of the balance before under the microscope in this video, but if you have those screws, the screws on watches that are regulated this way are a bit different. But basically, the more you turn the weight to the outside, the more influence it has. And that's what they use. However, to maintain the center point of gravity in the middle, if you screw out here a bit, you also gotta do it on the other side to counteract, because otherwise you are disturbing the center point of gravity. And yeah, that's another thing I wanted to talk about, because yeah, it's a bit adjacent to it. So yeah, that was it for this video. I hope it was informative. A bit of another style of video, but it was the only way I thought I could do this video. So I hope you liked it. If you have any questions, because this is a bit of like heavy theoretical stuff. Okay, it's a bit practical too, but I hope one day I can show the practical side of this. But yeah, if you have any questions, comment section down below. Otherwise, well, hope you like this video. See you in the next one. Bye bye.